All right, so we're going to move into the last section of Unit 7, 7.3. A little bit longer of a video or of a presentation, so you may want to split it up in a couple days. A lot of vocab here, very important for you to know the vocab as far as the types of chemical reactions. Okay. All right, so the rates of change. So to increase the rate of a reaction, there's a lot of different ways we can go about that. So what we mean by increase the rate of the reaction means make it happen faster. You can increase temperature. Remember, temperature is a form of energy. You raise the temperature, you're raising the amount of available energy. You're making particles move faster, so to speak. Increase surface area, concentrated solutions, and increase pressure. Oh, sorry. All right, so rate of change continued. Massive or large, bulky molecules are going to move slower than smaller ones, and that's important to keep in mind when we think about how fast a chemical reaction may occur. And we can add these things called catalysts. The catalyst is going to be an important vocab term for you to know. So a catalyst is a substance that's going to speed up the chemical reaction without permanently being changed itself. They are not reactants nor products. What catalysts do is they lower the amount of activation energy or energy needed to start the chemical reaction. Enzymes are proteins that are catalysts for chemical reactions in living things. If you think back to biology, we talked about salivary amylase, which is an enzyme in your saliva, which begins to break down complex sugars or starches prior them reaching your stomach with stomach acid. So that speeds up that chemical reaction. It speeds up the process of breaking down that particular molecule. Inhibitors are substances that are used to combine with one of the reactants to prevent certain reactions from occurring. An example of this is food preservatives, food preservatives, lemon juice on a cut piece of fruit to keep it from turning brown. So inhibitors are something that keeps a reaction from happening. Equilibrium systems, some reactions are reversible, which means that they happen just as much from left to right as they do right to left. Okay? Equilibrium results when the rate is balanced. So this is when the reaction moving one way equals the reaction moving the other way. All right, so there are 5 main reaction types in chemical reactions. You have synthesis, decomposition, single displacement, double displacement, or combustion. Notice after the displacement, you also see replacement. Some books or textbooks call it single replacement or double replacement. You'll see some put it as displacement. Both are correct. The displacement and replacement is used interchangeably. All right, so keep in mind what a chemical reaction is. Okay, as far as the equation goes. So a synthesis reaction. This is when 2 or more substances are put together to create one compound. So the generic equation for this is A plus B yields AB. Synthesis reactions always join a substance, so the product is more complex compound than the reactants. Okay? 2 or more substances are brought together to create one product. Right? That's a synthesis reaction. Decomposition reaction is going to be the opposite of a synthesis reaction. So it's when you start, where the reactant is one compound, and the product is going to be breaking that compound into its smaller pieces. So the generic equation is AB yields A plus B. Decomposition reactions break apart so that the reactants are more complex than the products. A single displacement reaction is when one element replaces another element in a compound. Generic equation is A plus BC yields AC plus B. And so what you see there is we basically traded the places of A and B in this reaction. Generally, a more reactive element will take the place of a less reactive one in a single displacement reaction. Next is the double displacement reaction. So the positive ion of one compound replaces the positive ion of the other to form two new compounds. So the generic equation is AB, which is one compound, plus CD yields AD and CB. And so we've swapped which atoms are in which compounds in both compounds. So the double, meaning two, displacement reaction. Next, you have a combustion. Combustion reactions use oxygen as a reactant, and usually carbon dioxide and water are going to be products that are made. So combustion is things burning. So flames burning can't happen without oxygen, and some very consistent products are going to be carbon dioxide and water being put off. All right, so a mole, we've talked about a mole, but it's back before Christmas. So mole is the SI base unit that describes how many tiny particles make up a fixed amount of a pure substance. So if someone counted how many grains of sugar were in 180 grams and found that there was that really long number of grains of sugar in 180 grams, so you see the abbreviation there. So Avogadro's constant is the number of particles in exactly 1 mole of a substance. This number is used to calculate the molar mass of a substance. The molar mass is used to compare the number of particles of each substance in a chemical reaction. That is the end. So those last few slides there were important vocab terms. We'll do some work with mole calculations here in a couple weeks. If you have questions, let me know. Be sure you complete the form that goes with this video, and we will move into doing quite a bit of practice next week. If you need anything, let me know. Thank you.